Hi, everyone. I'm going to go over a bit about the syllabus of the class with you to tell you a little bit about the kinds of topics that we'll be covering and the skills you'll learn during the class. So and this is a list of topics we'll be covering. It's roughly approximately a week each, but some of the intro topics we'll be covering over and over again and come back to practicing those skills. So we start by practicing an intro to coding. We'll be using MATLAB, as you hear a little bit about in another one of these little intro segments. We'll do some of the beginning stuff, getting you started, loading everything. And the first thing we'll be doing is making some simple plots and loading data and managing the data. So we'll be using both a little bit of made-up data as well as data from real experiments to get you comfortable with the idea that data are just numbers we have to load into MATLAB. So then we're going to go into a little bit of doing math, and we're going to be talking about systems of equations. Now, systems of equations are an incredibly powerful tool for describing and modeling data. And so we'll be talking about it in abstract, as well as showing the variety of applications that we will be able to practice once we understand systems of equations. A lot of different problems break down to solving systems of equations. Including fitting data. So we'll be talking about both the basics as well as a little bit more advanced topics in terms of how do you fit data. And regression comes out as one of the techniques, more statistical techniques in terms of fitting data. And then we're going to jump into much higher dimensional data, talking about big, complex data. And one of the most powerful tools in looking at high dimensional data is principal components analysis, PCA. And we're going to be talking both about the theory of PCA as well as how to practice it. And we'll talk about some examples of where PCA has been really, really powerful in terms of understanding biological data sets. And there's a couple of slightly more advanced topics that we'll cover towards the end of this course. One of them is a Fourier transform, otherwise known as the fast Fourier transform, the FFT. We'll go over how to use the Fourier transform to do time series analysis. So biological data sets where things are changing and there's a lot of dynamics. And so the FFT will handle a lot of those different kinds of topics when there's things changing in time. And lastly, but definitely not leastly, we'll be talking about numerical integration and differentiation. So these are topics that you may have heard about in your calculus class. We'll be doing kind of the same types of topics, but from a numerical and computational perspective, because you can't just take a derivative of data, right? But so in order to take a derivative, integrate data, we have to do it in a numerically stable kind of way. And so this is really an intro and launching you into the whole wide world of biological modeling. And so that's a little bit about what we'll be covering in this class.